Hello everyone. Today we will learn sheet metal bending and how to calculate its development length and where to place bending center line. So let's start. Right now I am using sheet metal environment. I am going to create one model first. Later I will explain you in detail. So I took an tab command. Will create some sketch. I created one rectangle with 200 length and 150 width. Its thickness is 10 mm. Later I taken the flange command. We'll create range of 150 mm length and its bend radius is 10 mm. So this is my example. Its height is 150 mm, width is 200 mm, and depth is 150 mm. Its bending angle is 90 degree and bending radius is 10 mm. So for that, to calculate development length, we have to calculate the A also. See, from that center of circle to the edge, its length is 130 mm, because that 10 mm thickness and the 10 mm radius is got minus from 150, remaining is 130. Same is here. In 200, the 20 mm is get reduced and 180 mm is remaining. And if you add A to the 180 and 130, then you will have your bending center length. Sorry, bending development length. So I have one formula. To calculate A, it's T by 3 plus R into 1.570 S. T is the sheet metal thickness. R is the inside radius. For bending, generally you always have to take inside radius as 1 to 2 times of sheet thickness. I always take whatever is the sheet thickness is the inside radius. So always do that. It will be easier to calculate. So A comes as 21 mm by that formula. Its formula is for 90 degree. For other degree bends is also I will provide the formula at the last of the video. So A is come as 21 mm, and to calculate development length I will add 180 plus 130 plus 21. So my total length is 331 mm. It's a development length. So before bending, you have to cut in the length of 331 mm by 150 mm to make this object. And the second part is you also have to calculate where to place that bending center line. So before giving to bending, you have to mention the bending center line distance from any edge, so that bending operator will create a bend of 90 degree and you will get this object. So to get that bending center line from any edge, you have to take this distance. If I take is 130 mm, and if I take the half of the AMM, I will get a bending center line distance. Same I have shown in here. It's 331 is the total distance right now, which is development distance, and distance from any side, which is 130 or 180 you can take. I took 130 mm plus A by 2. My A is came as 21 mm. 21 by 2, the distance is came as 140.5. From any edge, if you put 140 center line on 140.5 mm, you will get this object. In the bending operation, the material get stretched in the bending region. So it's not like that. If you consider that the development length is 200 by 150, 200 plus 150, it doesn't go in that way. It's like a 350 mm. But if you see the development length, it's less than 351 mm. It's 331 mm. So there is a difference of 20 mm. So that's why you have to calculate the development length. It will be always less than your bent length. This formula is I already applied in so many applications, and it gives so much accurate results. So you can use this formula and you can calculate the development length. So right now we will switch to other formulas also for other than 90 degree. If the inside radius got changed, what to do? So I have the list of these formulas. I will explain to you. If inside radius is smaller than the sheet thickness, consider my sheet thickness is 10 mm and inside radius is 5 mm. For 90-degree bend, this is the formula. Thickness by 4 plus r means inside radius into 1.5708. Whatever the is comes, you have to add in that remaining two distances and you will have your development length. For 1 degree bend, for other than 90-degree bends, what we have to do is to calculate for 1 degree bend what is the a and multiply with the angle which is you having. If you are calculating for 100-degree angle, calculate for 1 degree and then multiply by 100-degree, you will have that development length a. If the inside radius is from vary from 1 to 2 times the sheet thickness, if the sheet thickness is 10 mm, you have taken inside radius as a 20 mm, then you have to use this formula. Or if you are taking 10 mm also inside radius, then also you have to use this formula, t by 3 plus r into 1.5708. In my example also, the sheet thickness is 10 mm, inside radius is 10 mm, so I taken the that formula a is equal to t by 3 plus r. And if the inside radius is more than twice of the sheet thickness, means if the sheet thickness is 10 mm, inside radius is about 20 mm, then you have to go for these formulas. But I will generally prefer you to take inside radius same as a sheet thickness, so it will make your calculations also simple and to get development length. So if the inside radius is more than twice of the sheet thickness, for the 90-degree bend, thickness by 2 plus inside radius into 1.5708, and for 1 degree bend means other than 90-degree, t by 2 plus r into 0.01745. These formulas are validated and used most of the cases. So whenever you have to uh, calculate the development length, blindly use these formulas, get development and do your processes. Thank you.